Method 1 or method 3. So method 3 is the one that you can use to know the math. You just pick out the information. So what is the y-intercept?
4.
4. So you put your straight line, you get the line total. And the y-intercept is 6. So there's your y-intercept. And you know it's a positive slope. Why?
Because it's positive.
The 4 is what?
Positive.
Positive. So the line's going to go something like this right here. It's going to go left to right, upward.
Okay.
So all you have to do is go up 4 or down 4, whichever one you want to do. I'm going to go down 4. 1, 2, 3, 4, and then over 1, because it's vertical over what? Horizontal. And that's it. And that's how you do it. Remember, I got the handouts up here. Well, I think still got some handouts up here. And it goes over the graphing methods. There's only 3. And this one is method 1 or method 3. Okay? All right, now today's class we're going to start basically the beginning of the end of the last test. And it's going to cover, this is basically Unit 4 and Unit 5. I'm skipping Unit 3 because Unit 3 is not that detrimental to passing college algebra, because if you're lucky, you might get to Unit 3 in college algebra at the end of the semester, but highly unlikely. Because I barely got to it last semester in Math 110. Go ahead and start this recorder also, since I brought all my stuff today. What day is today? Today's the 9th?
Yes.
So this is basically Unit 3, or Unit 4 and 5. And I'm going to put it all together. First thing we're going to talk about is radicals. Now, there's a lot of different rules with radicals. The first rule is the parts of the radical. There's the radical, and right there, there's a number there. It's called the index. If there's nothing there, it's assumed to be what?
1,
2.
2.
Because the square root is your first actual radical. Under this, under the radical, is called the radicand. And the radical is the actual check mark thingy. All right, when you have an even root, you cannot take the even root of a what? Of a negative. You cannot take the even root of a negative. But you can take the odd root of a positive or negative. So, the only thing that you can take the even root of is a what? Positive number. And you can take the odd root of a positive or a negative. Example. Square root of 4 is equal to positive or negative 2. Square root of 4 is a positive number. Square root of negative 4 is not doable, so you have to do something to it. You have to break it up to the square root of negative 1 and the square root of 4, and then the square root of negative 1, we're going to get into later, is I, and the square root of 4 is 2, so your answer is 2i, but we'll get into the i's later. So that's what happens. Either it does not exist, or you're going to do this later. So we put an x through square root of negative 4, because you can't take the square root of a negative. The cube root of 8 is equal to 2. The cube root of negative 8 is equal to negative 2. So you can take the cube root of a negative number and the cube root of a positive number. So that's one of the first rules of radicals. Second rule of radical, or another rule of radicals, adding and subtracting radicals. You can do it as long as the terms are alike. 2 square root of 3 plus 7 square root of 3 is equal to what? Okay, let's go back to pre-algebra. 2x plus 7x is equal to, therefore, 2 square root of 3 plus 7 square root of 3 is, there you go. So square root of 3's are treated just like x, combined what? Like terms. Simple as that. So if I give you 4 square root of 2 minus 3 square root of 2, that's going to give you what? 1 square root of 2 or square root of 2. Now a lot of people say, well, how do you know when to leave it square root of 2 and when not to leave it square root of 2? Well, exact answer, when the directions say leave an exact answer, that means square root of 2. It means leave the radical. When you're doing homework problems or test questions and the directions say put the answer in exact terms, then that means leave it in the what? Leave it in the radical. An approximate answer would be 1.41 dot 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 dot, meaning you did it in the what? Calculator. So that's how you add or subtract radicals. Now, there's just one more thing I need to tell you about radicals, and that's sometimes you might need to break them up. And we're still in adding and subtracting radicals. So let me go to the next page and tell you what I'm talking about. 3 square root of 5 plus 2 square root of 10, or square root of, hold on a second, I'm thinking, 20 is equal to what? Well, the first thing you'd say is, well, Hubert, they're not the same. But you can break the square root of 20 up into what? Yeah, starts with
4 and 5.
4 and 5. So that'd be 3 square root of 5 plus 2, and I'm going to do this right here. I'm going to change this guy, whatever. Just forget it. I'll change this guy to red, square root of 20. And then this to square root of 4, square root of 5, sorry. So, does people not realize I teach? I mean, my neighbors really, I mean.
I probably got a question about the calculator.
Huh?
You probably have a question about the calculator.
Yeah, that one, she hadn't called me back since that night. All right, so next step, 3 square root of 5 plus 2 times what? What's the square root of 4?
Oh, 2.
2 times square root of 5. And now you've got 3, square root of 5 plus, what's 2 times 2?
4.
Square root of 5. And your answer is
7 square root of 5.
7 square root of 5. So you need to write this one down and put a mark beside it because some people forget how to do these. Out of all the rum happy, is that rum happy or rum?
Run happy.
Oh, I thought it was rum. Okay. All right. 7 square root of 5. I thought you were an alcoholic or something. 7 square root of 5 is coming from this. This one right here, or this type of question, is the one that I'll put on a test and people skip it because they can't remember how to do it. They can remember this stuff right here. They can remember that, and they can remember this stuff. But when you get to this is where that one right there is the one they freeze up on because they forget to break this up into something that you can take the square root of. Or this could be, square root of 16, which is 4. 4 times 2 is 8, and that would be 8 plus 3, which is 11. But the main thing is to get this 5. The most important part is to get like what?
Like terms.
Like terms. Just like the x's. 3x plus whatever x. These are like terms, and that's what you're trying to do in the problem. Okay? Now, what about multiplication? Well, multiplication of radicals is real easy. You just do it. 2 square root of 3 times 4 square root of 4 is equal to 8 square root of what? Well, what's 3 times 4? 12. Now, you can't stop here because that number right there has a perfect what in it? Has a perfect square in it. 4, Hubert. That's right, class. So, 8 times the square root of 4 times the square root of 3. And what's the square root of 4?
2.
2, so that's 8 times 2 times the square root of 3. And what's the final answer?
16 square root of 3.
There you go. Hopefully some of this stuff is, review for you. I don't know. And division. Division is real easy because you don't want a radical in the what? Denominator. So most of the time when you are dividing, you're going to try to get the radical out of the denominator. I'll give you an example. 1 over the square root of 3. I see I'm dividing a number by a radical. But you shouldn't look at it like that. You should look at it as, there's a radical in the denominator, I need to fix it. So what you do is you multiply by, you multiply by a factor of 1. Factor of 1 using the radical right here. So square root of 3 over square root of 3 is what you multiply by. If this was square root of 16, you'd multiply by the square root of 16 over square root of 16. If it's square root of 101, you'd multiply by the square root of 101 over square root of 101. Now the rule is that when you do that, what's the square root of 3 times square root of 3? Square root of 9, Hubert. That's right, class. And 1 times square root of 3 is 1 times square root of 3. And what's the square root of 9?
3.
It gets rid of the denominator. So. And that will always happen when you multiply by another square. Okay? So let's do another Square root of 2 over square root of 7. Try that one. Miss Turner had to go back to the doctor. Had to go to the doctor's office yesterday. That's where she was. Had to go back today. Nothing wrong with her. Probably alcoholism or something. All right. So multiply by what?
Square root of
Square root of 7 over.
square root of 7.
And what's the square root of 2 times square root of 7?
14.
And what is square root of 7 times square root of 7? Square root of 49, which is
7.
7. Now, why didn't I break 14 up into anything?
Because you just get back to.
Well, that, but 14, the only multiples of 14 is 2 and 7, and you can't take the square root of either one of those. And that will give you this right here. So, now sometimes you might get a number out here like the square root of 16, and the square root of 16 comes out to be 4. And you could keep going and have 4 over 7 if it was square root of 16. So it's different each time. So don't think just because you get to this point you're done. Yes, ma'am.
So if it was 16 and you had 4, the square root of 4, would you make that 2 as well? Or would you break down to be 2, or would you keep it as 4?
I'm just saying if you came out with 16, square root of 16 over 4 here. Square root of 16 is 4.
Mm-hmm.
So you would have 4 over 7 right there. That's it.
Got it.
You don't break it up into the square root of 4 times, no, you don't do that. You just say, if this was, let's say the square root of 25. The square root of 25 would be 5 over 7. But what I'm trying to tell you is not all the time will this give you a somewhat prime radical. Sometimes this will give you a number that can be broken up into another perfect radical. Okay? Now, there's one more thing called the conjugate. Now, some of you may have heard of conjugal, like conjugal visits at the prison. That means dang old opposite what? Sex. All right. So, conjugal or conjugate means what? Opposite. So the conjugate of x plus 2 is x minus 2. Conjugate of a minus b is a plus b. You get the point? So sometimes you might have a problem that looks like this. Okay, but the main thing is, what do you have in the denominator? You have a square root. You have a radical. So you need to switch it. So what is the conjugate of square root of 2 plus x? Square root of 2 what? Minus x. And what does that give you right here? Shortcut number 3, Hubert. That's right, class. And that's what it will always give you. When you use the conjugate will always give you shortcut what? Number 3, which does away with the radical, because when you square a radical, it goes away. So, I'm going to put the baby step in here. That would be 4 times the square root of 2 minus x over, and I'm just going to put it in shortcut number 3. That'd be square root of 2 quantity squared minus x quantity squared. And what happens to the square root squared? What happens to that? They cancel out and it just leaves 2. So you get 4 times the square root of 2 minus x over 2 minus x squared. Now, I could simplify that on, I could distribute, okay? I'm not worried about that. The only reason I'm showing you this is to show you that when you do the conjugate over itself, it will give you shortcut number 3. And shortcut number 3 will basically get rid of what? The radical in the denominator. Now I've basically gone over unit 3 or unit 4, but it's not that big a deal because I'm going to give you, most of your test is going to be on unit 5 or unit, the quadratics, because the reason I had to show you this material is because you need to know what a radical does in unit 5. Unit 5 is the most important section for Math 110. So that's why I'm doing this just to get to unit 5. Okay? But I still want you to do the homework for unit 4. So make sure let's go over this right quick. Unit 1, you've what? Done. Okay? Unit 2, you should be doing or done right now, halfway, not done. Okay? All right? And unit 3, we're going to skip because I told you I was going to go over the most important. Unit 4, I want you to work on the homework, but we may or may not have a test on unit 3, or it may be, unit 4, or it may be incorporated with unit 5. Now, the first thing people's going to think is, oh God, you're putting it all on one test. No. First of all, let me tell you this. Unit 5 is just one concept. That's completing the square. That's it. That's all there is to it. In fact, I've modified college algebra because I'm in charge of college algebra. I modified it to where you don't do anything in the first couple of units except for completing the square. That's it. So unit 4 is just one concept. I'm sorry, unit 5 is just one concept. Unit 4 is several concepts I just went over. Okay? Adding and subtracting, multiplying, dividing radicals, simplifying radicals. That's 3 or 4 concepts. This is just one concept. So your last test, which will end during the week of finals, which is, I don't know, next Monday, next Wednesday or Thursday, Tuesday or Wednesday, is going to be on this right here. Okay? Now that I've gone over unit 4, I can start on unit 5. Now, you remember when I told you about the family of graphs, and I told you that you had your family of graphs, and this is x to the first, and this is a straight line, and this is x to the second, and what is it? A parabola? Okay, now the parabolas, that's what unit 5 is all about. Okay, so that's what we're going to focus on. Before, I used to give you something like this. Y is equal to x squared plus 4x plus 4. Or, hold my pinky up, f of x, let me hold my pinky up, is equal to x squared plus 4x plus 4. And I told you to factor it and it would give you blah, blah, blah. Well, when you set y is equal to 0, what are you finding? Method 2, graphing. When you set y equal to 0, what are you finding?
The x-intercept.
The x-intercept. So when you're solving this guy right here, you're basically finding the what? X-intercepts. With the y-intercept, you already know. Plug in 0 for x. That goes out. That goes out. So what is your y-intercept?
4.
Your y-intercept is right there. So you already got your y-intercept, and we're going to find the x-intercept. And we're also going to find the vertex using completing the square. Vertex is your highest or lowest point. So what I'm trying to tell you is, with completing the square, that's what CTS is, completing the square, you will be able to, you already have the y-intercept and the x-intercept, and you'll be able to find the vertex. So technically, with the completing the square, you'll be able to sketch the parabola without even plotting points. A bunch of points. Now, a lot of you say, well, we just do use the reverse FOIL here. Well, what is reverse FOIL in shortcuts? The reverse FOIL in shortcuts is a form of what?
Completing the square.
No. Starts with F.
Factoring.
Yes. This is a form of factoring. Well, that's fine and dandy, unless what? Unless the trinomial is what? Prime. Then what do? You skip the problem and go to the next problem, right? Or you erase the problem and say, or it cannot be done. That's what you say.
No solution.
No solution. Yes, exactly. No. Completing the square is the granddaddy. Completing the square has no restrictions. It will give you the x-intercept no matter what they throw at you. Now here, my teacher taught me the quadratic formula. The quadratic formula is good for two things. And if they are watching this video, fine. I'll be glad to debate it with them no matter what. The quadratic formula is basically made to make you depend on the calculator, and it's good to use for decimal quadratics. Now I'm being a little bit facetious here. But the reason it's good for decimal quadratics is, what is a decimal quadratic? It's a quadratic made of what?
Decimals.
Decimals, which is tedious what? Math. So you use the what? Calculator. Now, you're against the calculator. No, I just said, when you have decimals in your quadratic, you need to use the what?
Calculator.
Did I say depend? No. When are you depending on it? When you use it for whole numbers in your quadratic, like 2 and 5. That's when you use completing the square. Why? Because you don't need the calculator at all, because all you use is 2nd through 4th grade mathematics. You know, 2 plus 4 is 6. 1/2 plus 1/2 is 2/2. You know, that kind of math. So, let's talk about completing the square. First thing, move C. Second thing, add blanks, both sides. First question I get when I do this is, where do you move C? Well, wait till I do a problem first. And the second thing I get, add blanks where? Well, just wait till I do a problem, okay? Third is the most important because that's the actual completing the square. You're going to take B, divide it by 2, and you're going to square it. And you're going to take that answer and put in both blanks. 4. By using number 3, shortcuts number 1 or 2 will be the left-hand side. 5. After you have gotten shortcuts 1 and 2, you basically have A times x plus h, quantity squared, is equal to k. And here, you go 2 different directions. Get your vertex and x-intercepts, and we'll do that after we do the problem. What is positive k? What is h? Your horizontal what? We went over it last week. Horizontal what? Shift, Hubert. That's right. What's k? If h is the horizontal shift, what is k?
Vertical.
Vertical shift. So you know where the vertex is. So let's do an example. And a lot of you saying, oh God, I don't know what he's talking about. Well, by the time we get through doing 1,500 problems in the next week, then you will be very efficient at this. Sorry. So, let's go with something that cannot be factored. X squared plus 13x is equal to, or 13x plus 4 is equal to 0. Okay, y is equal to 0, so I'm trying to find your x-intercepts. So I can't factor it because I know that 1 times 4 will not give me 13, and I know 2 times 2 will not give me 13. So I know this is prime. So I move C. Well, what is C? Well, those of you that have studied the quadratic formula know that C is equal to what? 4. So if I say move C, let me ask you a question. What side of the equal sign is it on right now? It's on the left. So if I tell you to move C, where is the only place you can move it?
To the right.
To the right. It's rocket science. X squared plus 13x plus blank is equal to -4 plus blank. And I added my blanks.